Hello, and welcome to a video presentation on parallel and perpendicular lines. Here's what you'll learn. How to identify parallel, perpendicular, and skew lines. And we'll also look at angles formed by transversals. What are parallel lines? Parallel lines are lines which lie in the same plane, and, even though they go on forever in two directions, will never intersect. Any parts of parallel lines, like line segments or rays, are also parallel. Can you think of real-life examples of parallel lines or parallel line segments? Most people immediately think of railroad tracks, and that's a good example. How about the steps on a ladder? The equal sign in math? Or the yardage markings on a football field? All of these are examples of parallel lines. The symbol showing two lines are parallel looks like this. What are perpendicular lines? Perpendicular lines are two lines that intersect at exactly a 90-degree angle. From certain angles, some lines look like they intersect each other. However, lines are not perpendicular unless they actually intersect and touch each other at exactly a 90-degree angle. Can you think of real-life examples of perpendicular lines? Well, how about the letter T? Most road intersections form a perpendicular angle, and the top edge and side edge of a door. The symbol for perpendicular lines looks like an upside-down T. What are skew lines? Skew lines are two lines that do not intersect and are not parallel. Skew lines reside in different planes. Some skew lines can look like they intersect when viewed from certain angles. However, truly skew lines will never touch each other. Let's take a look at some examples. Using the figure below, tell whether the lines specified are parallel, perpendicular, or skewed. Let's consider line BC and EF. Let's identify where they are on our figure. There they are. What can you tell me about those two lines? Those lines are parallel to each other. How about these two, line BC and DE? Again, let's identify where they are on our figure. There they are. BC and DE are skew lines. Finally, what about lines AD and AB? Again, let's identify where they are on the figure. There they are. Those two are obviously perpendicular lines. What is a transversal? A transversal is a line that intersects two or more other lines. The red line I'm drawing over top of these green lines is a transversal. Transversals that cut parallel lines have some special properties we want to address. When a transversal cuts two parallel lines, 8 angles are formed. 1, 2, 3, 4, 5, 6, 7, and 8. All of the acute angles in our figure will have the same measure. All of the obtuse angles will also have the same measure. Any one of the obtuse angles and any one of the acute angles, like angles 1 and 3, 5 and 6, or 6 and 8, for example, are supplementary angles because they form a straight line. When the obtuse and acute angles are added together, they total 180 degrees. Also, all angles directly across the vertex from each other have the same measure. So angle 1 and 4 will be the same. The measures of angle 2 and 3 will be the same, as will 5 and 8, and 6 and 7. These angles are known as vertical angles. Angles found between the parallel lines, angles 3, 4, 5, and 6, those are called interior angles. Angles found outside of the parallel lines, angles 1, 2, 7, and 8, Those are called exterior angles. Angles that are located on opposite sides of our red line, the transversal, are called alternate angles. Now, take a look at angles 3 and 6 and 4 and 5. They're located on opposite sides of the transversal between our parallel lines, so those are called alternate interior angles. Angles 1 and 8 and 2 and 7 will then be alternate exterior angles. If you slide an angle up or down the transversal, the red line, and it aligns with another angle, those angles are called corresponding angles. Take a look at the line segments that form angle 1 at the top of our figure. Now, if we could slide that down the transversal, we would see that it lines up with angle 5. That means angle 1 and angle 5 are corresponding angles. Some other corresponding angles are 2 and 6, 3 and 7, and 4 and 8. Knowing all of that, we can determine the measures of all 8 angles if we're given the measure of just one of these angles. For example, let's say the measure of angle 4 is 130 degrees. Then we know all other obtuse angles are 130 degrees as well. So angle 1 is 130 degrees, as is angle 5 and angle 8. Since the obtuse angle and acute angle pairs are supplementary, that means they total 180 degrees, all of the acute angles then have to be 50 degrees. So angle 2 is 50 degrees, as is angle 3, 6, and 7. Now let's take a look at another example. Describe the relationship between the angles listed. Consider angles 3 and 6 first. Take a look at 3 and 6. What can you tell me about their relationship? They're on opposite sides of the transversal. They're between the parallel lines, so that makes them alternate interior angles. What about angles 2 and 6? Look at those. 2 and 6 are corresponding angles. How about these two? 5 and 8. Take a look at angles 5 and 8. What can you tell me about those? They're directly across the vertex from each other, so that makes them vertical angles. How about angles 1 and 2? What would you call those? What's their relationship? Together, they would total 180 degrees, so they are supplementary angles. How about angles 1 and 8? What would you call those? Look at the relationship between 1 and 8. This time they're on opposite sides of the transversal, but outside of the parallel lines. So what do we call that? Alternate exterior angles. And finally, what would you call angles 6 and 8? How do they relate to each other? Well, those two are also supplementary angles because their sums would total 180 degrees. Now let's look at another example. Let's find the measure of each angle. The problem wants us to find the measure of angle 2 in the figure. Now, since the acute angles are all 75 degrees, we've been given one angle here, 75 degrees. That means all the obtuse angles have to be 105 degrees because an acute angle and an obtuse angle have to total 180 degrees. So in this case, since angle 2 is an obtuse angle, it's going to be 105 degrees. What's the measure of angle 8 in the figure? It's right across the vertex from angle, what would be angle 5. We've replaced it with the number 75. So its measure is 75 degrees. It's an acute angle. Finally, what's the measure of angle 1? It's also an acute angle, so it's also going to be 75 degrees. Congratulations! You've learned how to identify parallel, perpendicular, and skew lines, and angles formed by transversals.